Alright, so what are we going to do with this? Well, I have a population mean and I have a lot of samples. So what I wanted to do is take samples and create confidence intervals. That's where the second page comes into play. Okay, so this is the one where the you have these lines going across the page and like one big line coming down the page. Alright, so this says 95% confidence intervals for random fill of 4 boxes where mu is 8.333, 8 1/3, n equals 20 for each interval. So what happened is that with 500 samples, I broke it up into samples of 20. So think of 25 different samples of size 20. Each sample of 20, I calculated a confidence interval using the calculation we did in earlier examples. And then I represented that calculation as a line on this chart. And I did that 25 times. Now they vary, because depending upon the standard deviation for that sample, depending on the mean for that sample, you got different confidence intervals estimating the population mean. So I'm using the computer simulation of filling in 4 boxes at random to estimate the population mean. And what's interesting is that unlike practically everyday statistics, we don't know what the population mean is. In real life, you're estimating it with a confidence interval. But in this case, I did know what the population mean was because I wanted to see what happened. Alright, so the vertical line going down the page is the population mean. And you'll see that in 25 samples, each line segment is crossed by the population mean. So it turned out in 25 different samples, actually all 25 samples captured the population mean in its estimate of the population mean. And one of them almost missed it, if I recall. It's the 4th one from the bottom. It almost missed estimating the population mean in its interval. So now, with 95% confidence, I would have expected one of these to have missed the population mean, because we're be wrong 1 chance out of 20. So, but that didn't happen. They happened to all fall within the range. So I thought that was neat. So here are all these confidence intervals, and they did indeed capture, or the population mean fell within the estimation of the population mean provided by the samples. So I hope that made some sense. There's a very similar chart in the book. We'll find it here in a minute. But I also want to draw your attention at the bottom of the page. Instead of doing samples of size 20, I calculated a confidence interval using all 500 samples. So you'll see a bold print little segment near the bottom, a little short one. That's the confidence interval using all 500 samples. And in matter of fact, the population mean was right smack dab in the middle. So, but anyway, for a 500 samples, the confidence interval was much shorter, much more tightly focused. So, came out right on the money. In a sense, this verified my class's computation of 8 1/3. Had they made a mistake in calculating the population mean, I think it would have shown up in the random simulations. So that was kind of neat for me also. Well, about every time I do this class, well, most of the time I try to produce a new handout, and that was one of my favorite handouts. Now, I got the idea. It's not totally original. I got it from the book. The book really does the same thing. If you look on page 240, it has a similar type of scenario where he's done some confidence intervals estimating a population mean. So that was on page 240. Very similar. There's also another one I like on page 243. If you look here, he's done a bunch of different confidence intervals near the bottom of the page of 243. sample size 100, sample size 200, all the way down to 3,200. And what's happened is that the confidence intervals got shorter and shorter and shorter and shorter. Okay, so larger sample sizes, smaller confidence intervals. He's illustrating that. I like those kinds of examples in this book. I think they have some very creative samples, very creative examples in this book. Okay, there is a pretty neat story in here about the German tanks in World War II, and you can read about it in your book. I like it. During World War II, whenever we captured a German tank, we searched for its serial number. And the Germans, when they produced their first tank, it has serial number 1. The second tank they built was serial number 2, and so on. So, being somewhat anal retentive about these things, the German Army during World War II, when they produced tanks, they just numbered them. And so tank number 493 was the 493rd tank produced by the German Army. Well, so we would capture a tank, we'd collect those numbers. Using a little statistics, we produced a confidence interval estimate for how many tanks the Germans had made. And that's good intelligence. If you're fighting a war, you want to know what kind of weaponry your enemy has. So we were able to use estimation, confidence intervals, to estimate how many tanks the Germans had. Now, the Americans, much wiser about this. When we build a tank, we put a serial number on about this long, and you'd have to go talk to the Pentagon to figure out which number it is, because they use all kinds of codes. And so anybody capturing our tanks would have no idea how many we've made from the serial number, because it's all coded. So anyway, I love that. I love that example. Okay. Well, I'm going to work some other kinds of examples here. And the next example is estimating a population percentage. So let me find a good example in the book. My book is about falling apart here, the one I have here at home. So I expect it to just fall in a couple pieces one of these days. Alright, so give me a minute here to find one I really want.